Everyone. Um, it's good to talk about something during the holiday because obviously you're coming back to school. We ended on differentiation. I thought we kind of prepare ourselves. Now it's still on holiday, but let's do this. Differentiation is what we have been talking about. That's what we ended with. So I'm going to just explain differentiation. We have done a bigger chunk of it. Most of what I'm going to talk about is the use. So if you look at this, we already know that differentiation is the gradient. So when you do dy dx, what you are actually getting is the gradient. And we know the basics of that. We know that if I'm differentiating this, I'm actually dropping down this 2, so it will end up being 2 times 3. Then these 2's lose a 1, so I'm going to have 6x to the power of 1. So this is the answer. Differentiating 3x squared gives me 6x. We know this. But now, what are the syllabus requirements? Just a very quick one. Um, these are the requirements here. So the syllabus requirement is, first of all, you should know that differentiation is a gradient. A gradient is the main thing. All right. But then we also want to say this derived function, which is after you differentiated, what you get as a derived function can actually be used to get your turning points. Remember turning point? The top, this is a turning point where the graph is turning here. The turning point can also be like this. Okay, these are the two main turning points we're going to talk about. There is another turning point which looks like this. Okay, where mostly it comes from functions like cubic functions, where a graph is almost turning, but then it goes back again. So this turning point is not a minimum or a maximum. We call it a point of inflection. So, but for now, I want you to forget about this. It's not part of the syllabus. We are only talking about the minimum point and the maximum point, okay, which are all stationary points. Okay, so we also want to discriminate or to show the difference or be able to see the difference between a maximum point and a minimum point. How do we tell that this is maximum? How do we tell that this point we've got is a minimum? Okay, so we'll use differentiation to get the derived function, which is actually the gradient. So the gradient is the same as the derived function. What I'm going to have is an expression that expresses the gradient. So from that expression, we should be able to tell if that expression is for the maximum or if it is for the minimum, because there's going to be a certain point that we get which is for the maximum or the minimum point, which we also call the turning point, which we call the stationary point. Now, there's another statement here which says use derivatives of functions of this form, meaning anything you have which is expressed in terms of nx should be differentiate. You should be able to differentiate whatever has an x in it, or whatever expresses x, or whatever is expressed by x. You should be able to differentiate it, such as this one. This is the one which is being referred to here. Simple sums. This is a sum. There is this term which is x cubed. There is this term which is just an x. There is this term. These are all summed together. So we should be able to differentiate each one of these separately, but then put it back together. All right. So we have talked about this, and I'm really just rushing through the next few slides. We've talked about derivatives being gradient functions, and we have also learned how to drop down the n and subtract 1 from n. So we dropped down this n. This is the n we have here. And then we then subtracted the 1 from the one n on top, which is what we have here. So we've done two things. We drop the n, and then we subtract 1 from n. All right. So if we have y is equal to x cubed, what will be the answer? The answer there obviously will be 3 will drop down, and then 3 will lose 1. The 3 on top will lose 1, but then the 3 will come down. So we have the 3x, then the 3 will have lost 1, so it will be 2. So it will look like this, 3x squared. We have already done this, okay? So this is the one which we also said you can also express dy dx as f prime. It is not the f inverse which we've used in functions. F inverse means the inverse of a function, but now it is a prime. F prime here, this prime, implies differentiation. So instead of writing dy dx is equal to blah blah, you can also write f prime is equal to the following. So it can be f prime equal to the following, which is the same as dy dx. That is just notation. So finding dy dx of this one, the answer would be 7 will drop down, so it will be 7x. Then 7 on top will lose 1, so it will be 7x to the power of 6. So the answer will look like this, 7x to the power of 6. When you have x to the power of 5, 5 will drop down, but again the 5 on top will lose a 1, so it will be 5x to the power of 4. This is just how we differentiate. What if we just have an x? This means that there is a coefficient here which is just 1. All right. So since x is losing one step backwards, we have seen it here, it became 6. Okay. We've seen it here, 5 became 4. Okay. So now we know here there is a 1. So it will just disappear. So this 1, which is the coefficient, will remain on its own. So the answer is just 1. So the answer is just 1 because there is 1 here. There is a 1 which is a coefficient, isn't it? If this was a 2, then the answer would have been just a 2. If this was a 3, as long as x is just x, the coefficient remains alone every time. What if we have a constant? We talked about this as well. When you have a constant, the constant just disappears. I said this last time. A constant, when you have differentiated, ends up being just 0. It has just become 0. Okay, so let's continue. This is the same thing which we discussed. The difference here is that there is an a, which we did talk about, isn't it? So the n still will drop, but when the n drops, it will multiply with n, and then n will lose still, you will still lose the 1. So here is an example. What will be the answer here? 4 drops, so this will be a 12, then this will be a 3. This will be a 15 because it will multiply with 3, and this will be a 2. This 8 will multiply with 2, so it will be a 16, and here there will be a 1. So it will look like each part is differentiated on its own, each part on its own. So you remain with 12x cubed minus 15x squared plus 16x. This is the answer, isn't it? So we talked about this. What if we have brackets or something that needs simplification first? First, we are supposed to expand this double bracket and then come up with a quadratic, then differentiate, and then after that we have that as the answer, 6x minus 7. Okay, when you ask the question, find the gradient of a tangent. This is a cubic function. Okay, so cubic means, actually cubic means it turns more than once. It's not quadratic, so it turns many times. But what we want is the gradient at this point where x is 1. Okay, so where x is 1, wherever it is, we are going to have a tangent and then find m for this tangent. So what we'll be looking for is the gradient of this tangent. But how do we do it in differentiation? We differentiate it. Okay, so we differentiate. After differentiating, we say, oh, it is that x is equal to 1. So we place where x is, we put a 1. Okay, so we put a 1 where x is here, and we put a 1 here. And then, so this is what we have. So the answer is 13. It means this 13 is the gradient of this curve, this curve. Okay, the gradient is 13 because we've differentiated and placed 1 where x is. So this is what we have done, and this is what we get. All right, so this is okay. The gradient is 13. So finding the equation of a tangent, it's easy because we know how to find the gradient. If we found the gradient, and then there is a certain point that is given. So after we found the gradient, we know that a straight line is y is equal to mx plus c. So when we find the gradient by differentiating, we'll place the gradient here. Okay, and then we'll place this x here, and then we'll place this y here, and so we're going to know c. Then after knowing c, we are now going to know the whole equation of this tangent. All right, so look at this question. Find the equation. So we're looking for the equation, which is y is equal to mx plus c of a tangent. A tangent is y is equal to mx plus c. It's a straight line. So for us to find the gradient, we have to differentiate. As long as this word comes, the equation, an equation has got gradient. So as long as we have a question asking for the gradient in some form, we have to differentiate. After we differentiate, we can then place where x is, we place a 2. So that value, we place it, and then we're going to have the gradient. And then when we have the gradient, we look for c by substituting x and y into the y is equal to mx plus c. So this is what we have. We differentiate first, then replace x by 2, we get -3. And I mean, we differentiated here, then we packed this, then we got x is equal to 2 and place it in the original equation. Okay, so when we place x is equal to 2 in this equation, then we manage to get the value of y, which is -3. Can you see what is happening here? Okay, so what is happening is that um we we differentiated first, then got our answer, packed this, and then we went on to get x is equal to 2, placed x is equal to 2 into this to know y. So we've solved for y, and then y is -3. Okay, so we have x is 2 and y is -3. Now we go back to this one. We want to solve here now to know what the gradient is. So the gradient is now putting 2 where x is, here, here. We put the 2, which is x is 2, and then the answer is the gradient. So the gradient is -4. So now y is equal to mx plus c becomes easy because we know our coordinates and we also know the gradient, and therefore we put this together in y is equal to mx plus c. Maybe I'm a bit of a hurry, but remember I'm doing a video and I want to make you see this. So y is equal to mx plus c. We know the gradient and we also know the coordinates of x and y. Place them there, we know c, and therefore we have the equation of this tangent. Right. So turning points. This is the new thing. The other things were all things that we have already dealt with. Turning points. Turning points, we know already from graphs that a turning point is a maximum point or a minimum point, down or up. So this turning point is because the gradient of this line is 0. At every turning point, the gradient is 0. Every turning point, every turning point. At this turning point, the gradient, because when you've drawn the tangent is a slope which is a line which has no slope at the turning point, only at the turning point. Okay, because if I put a tangent here, it will look like it will come straight like this. So it has a slope. It's not 0. There's a certain slope. So there's a certain gradient to it. But at every turning point, the gradient is this. So it is just straight, and then it's not sloping. So every turning point divide the x is 0. So all the stationary points, all the turning points, divide the x is 0. So it is divide the x is 0 at p, q, and at r. Okay, but Q will be called the maximum point because it's a hill top, and then P and R are like a valley bottom, and therefore that those are minimum points. All right, but one thing we're going to see is as you are going to a minimum point, first you have a negative gradient because this is negative, then this is positive. So you come first negative, then you start going positive. It means you came from a minimum point. But if you went positive here and then later you come negative, so first you came positive, then you start going negative down, then that becomes a hilltop, which is a maximum point. All right. So, but at each turning point, the x is 0. So look at this. A curve has equation y is equal to 2x cubed plus 3x squared minus 12x. Find the coordinates of the turning point. This is a cubic function. It's likely to turn twice. Okay, it's likely to be this kind of a thing. All right, and a nice drawing, but yeah, something like that. So it is likely to be a thing which comes down and then comes up. So it will have two turning points, two places where divide the x is 0. So what do we do first? Differentiate. When we differentiate it, we equate the answer to 0 because that's what we know about turning points. Dy dx is 0. In this case, dy dx is 6x squared plus 6x minus 12. Equate it to 0 so that you can know what x is at the turning point. So we'll know the value of x here and the value of x here. So we now equate this derivative to 0. Equate it to 0, solve it, you end up with two answers. X is equal to 1 here, and also x is equal to -2. Okay, this is not written correctly. It's supposed to say x is equal to -2. Okay, so x is equal to 1 and x is equal to -2. Now, when x is equal to -2, then, right, what is y? Because we want the coordinates, isn't it? So we have to place this -2 into the original equation so that we can know y. So we place it in there. Can you see what is happening down here? So we've placed it, and then we know y is 20. When x is 1, y is -7. So now we have the two coordinates. This is one set, and this is the other set of coordinates. So now we know the coordinates of the two turning points. Now, um, if we know the coordinates like we have done now, the problem may be, are they maximum or minimum? Or is one a maximum, the other one a minimum? How can we do this? We can do this by saying, okay, this is the turning point we have. Okay, so what is the behavior of the graph before it reaches the turning point? Was it sliding down, and then after turning point it starts moving up, therefore it is a minimum? Or was it going up and then later started sliding down? Then that will be a maximum. So we have to know. We know the gradient is 0 at each turning point, but how was the behavior before and after the turning point? So the red sections of the curve show the gradient, where the gradient is negative. Yes, the gradient is negative as you slide down. The gradient is negative as you slide down. But the gradient will be positive as you go up and as you go up. Remember, from left to right is what we are looking at. So we are going this way. We are walking, going this direction. So here we are sliding, then here we are climbing, here we are sliding, and here again we are climbing. As we slide, the gradient is negative. As we climb, the gradient is positive. As we slide, the gradient is negative. As we climb, the gradient is positive. So when we are from negative to positive, it's a low point, so it's a minimum. When we are from positive to negative, it's a high point, so we are on a maximum. Those are the basic rules that I want you to see. So look at this. Okay, so what you see here is that um, at a maximum point, there is a positive first, then a negative next. It means you came from a. So, but what is positive and what is negative? It is the gradient, the dy dx before the point and the dy dx after the point. Let's see how we do this in an actual question. Okay, this is minimum. It means we came first down, so it was first negative, then later positive. So this is a minimum point. So let's rush through. Let's see. We have an actual question here. Now, in this question, we are saying find the coordinates of the stationary point on the curve. Okay, then how do we find the coordinates? Dy dx. Then dy dx, what do we do? Dy dx is equal to 0. When we do dy dx is equal to 0, we get the values of x, because then we say dy dx. So if we do dy dx is equal to 0, which I'm doing now, differentiate 3x squared minus 3, equate it to 0. So equate 3x squared minus 3 is equal to 0. Whichever way you solve, you can decide to divide by 3 everywhere. Then the answers will be 2 plus minus 1, because you are square rooting 1. So this plus minus 1 is the values of x. So the values of x where it is turning. So where this thing is turning, the value of x here is positive, the -1. The value of x here is +1. So there are two values of x at the turning points. But what about the values of y? If we know the values of x, we can substitute them in this to know the values of y. So now we put -1, we get 4 as y. When you put x is 1 into the original equation, the original thing, this is where we are substituting the values of x so that we know the values of y. So now the value of y is 0. So we have the two stationary points, okay? These two. We have -1, 4 and 1, 0. Now the problem now we have is determining their nature, okay? This. Is this, are these 2 points, which one is maximum, which one is minimum among these 2 points? So we said, how do we do this? We said we have to check before the turning point and after the turning point. Now let's see how to check. How do we check this? We can use such a thing. All right. Now, the point here, the first point we are checking is -1. Before we check this other one, first let's check -1. So look at the drawing. This is -1 here. Can you see -1? Therefore, after -1, we have -0.9. Before -1, we had -1.1. So -1 is here. Before it, there is -1.1. Isn't it? So after that, we have -0.9. So on the sides of -1, there is -1.1 and -0.9. Now let's check how dy dx works. Okay, so remember we came from dy dx is this one, 3x squared minus 3. So it's the one we are checking. So this is now the one, 3x squared minus 3. When we put negative 1.1 in our derivative, when we put negative 1.1, the answer is a positive. Therefore, it is going upwards. When we put negative 1.1, I'm repeating, the dy dx yields a positive answer. If you do this negative 1.1, you square it, it will be like 1.21 times 3. It will be like 3.6 or something. Minus 3, it will be like 0.6. So it is a positive because it's a positive answer. Therefore, it is a climb on the hill. Okay, then we know at negative 1, it is 0. At negative 1, the gradient is 0. So it is a flat top. Okay, then when we put negative 0.99 square, it will be a negative answer. Therefore, it is dipping down. So we know now the curve behaves like this at negative 1. Hope that is clear. If we've checked this one, then we have also now to check 1. How about at 1? How does it behave? So what points can we pick? At 1, we can pick, if 1 is here, what is less than 1? Immediate less. Let's say we take to 1 decimal place. We would get maybe 0.9 on the left and 1.1 on the right, just to go one step. So look, we pick, this is the 1, this one here is this one here. Okay, before it there's 0.9, after it there's 1.1. So we do what we did at first. We put 0.9 into our derivative, test it there, it gives a negative answer. Then we get our 1.1, we put it in our derivative, test it there, and it gives us a positive answer. Therefore, it is from negative through 0 to positive. So it's a smiley face. It's a minimum point. So the first point, this one was a maximum, yeah? And then this one is a minimum point. Okay, so we can tell maximum and minimum using this test. We have tested using the derivative dy dx. So we have tested. And so we can tell minimum point and maximum points. Okay, then we can sketch it. How do we sketch it? We know where negative 1 and 4 are. So we place it here. And we know where 1 and 0 is. So we place it here. We know this is maximum. So we kind of put an arc like this. And we know this is minimum. So we put like this. Then we know this is the C. The number that always remains alone in a cubic or in a quadratic graph, this number is always the C. C means the y-intercept. It's always where it cuts the axis or the y-axis in particular. So it has cut this graph or this expression is being cut at 2. So we put 2 here. So we know it will cut at 2 as it is going towards the minimum. And then we can just extend this side as a curve and extend this side. This is the drawing. Okay, have a review of it. You can look at it, but we know maximum and we know minimum. Therefore, it is easy for us to know where C is. Okay, then there's what we call the second derivative. What is the second derivative? The second derivative is actually deriving the second time. When you differentiate the first time, then you differentiate the second time. Okay, so you differentiate twice. So to differentiate the first time is dy dx. To differentiate the second time is to differentiate what you differentiated before. So you get what is called this, the d2y dx2. It means you have differentiated an expression twice. So we've differentiated something twice, and it's called the second derivative. Okay, let's differentiate this twice. This is easy. Differentiate it once, you get 5x4 plus 8x minus 5. Differentiate it twice, you have 20x cubed plus 8. You've differentiated it twice. But why do we need to differentiate twice? Differentiating twice helps us to know the nature of a turning point. It helps to know whether this is a maximum point or a minimum point where dy dx is 0. This. Where dy dx is 0, it is easy to tell whether it's maximum or whether it's minimum using the second derivative. So let's use the second derivative to know this. Now, we consider moving from left to right. As always, we move from left to right along the x-axis. Okay, so as we move there, dy dx shows us like if we've moved the way this is showing here, um, what is dy dx doing here? It is actually reducing, it's decreasing, because it's from a positive through 0 to a negative. So what is happening? From positive, you go to 0. You're going downwards from positives to 0 to the negatives. It means you're going low, isn't it? So it is dy dx, it has started positive, it decreases to 0, and it goes to a negative. So it's actually decreasing. It's decreasing. Dy dx is decreasing. Now, okay, why are we talking about this? If dy dx is decreasing, to check dy dx, we do dy dx on dy dx. So we are differentiating twice. Okay, so we are now, all the explanation here just means, can you dy dx on the first dy dx? So it becomes the second derivative. Then now the second derivative will perform like this. If it is a turning point, remember dy dx is 0 is a turning point. So if it is a turning point, then you check the second derivative at the turning point. So you do dy dx is equal to 0 because you know it's a turning point. Then you do another dy dx on the same turning point. Now, if dy dx gives you a negative, if dy dx gives you a negative answer, I mean, if the second derivative d2y dx2 gives you a less than 0 answer, then the point is maxima. Have you heard that? If the second derivative gives you a negative answer, then it's a maximum. So it kind of works in the opposite, isn't it? It is giving you a negative answer, but then you have a maximum point. The same thing happens with um, when you have a minimum point. For a minimum point, the second derivative should give you a positive answer. This is all you should know. For a minimum point, the second derivative is positive. For a maximum point, the second derivative is a negative. That's all. So there's a question here. Find the coordinates of the stationary points on this curve. So we're going to find the coordinates of the stationary point. So we're going to do dy dx is equal to 0. First derivative is equal to 0 will help us know the points themselves, like this. We differentiate, we get 3x squared minus 12. We equate 3x squared minus 12 to 0 and get the 2 points. Okay, get x is plus minus 2. X has two positions. So what are we doing now? We are now trying to get the 2 points. So when x is negative 2 here, this one, we put it inside this to get y. So y is 21. Then when x is positive 2, y is negative 11. So we have the 2 points. This is a turning point. This is a turning point. Now, when you have the two turning points, what is the problem we need to do now? We want to differentiate the second time, because the question says get a second derivative and test the nature of these 2 points. These 2 points, we need to know their nature. Too many lines, isn't it? Okay, good for the eyes. Okay, so let's get the two stationary points. Check if they are positive. We're going to use the second derivative, but we know what is really the issue here is the value of x. Remember, it's always the value of x that really matters. So there is a value of x which is negative 2. There is a value of x which is 2. Let's check this. Here is our derivative. We differentiate again. What is the final answer? 6x. So now we go back and get the two values of x. There was a negative 2 and a positive 2. The one that will give us a negative answer is a maximum point. The one that gives us a positive answer is a minimum point. Now check. When we use negative 2, the answer is negative 12, isn't it? Because it's 6 times negative 2. Therefore, it is a maximum point. Then when we use x is equal to 2, it gives us positive 12, which is greater than 0. Therefore, that one is a minimum point. So this really is why we are differentiating. We want to know the turning points, and we want to know how they are behaving. Are they maximum or are they minimum? This is what differentiation is about. Okay, so I want you to go through this and me know how things look. I hope they look up, but soon you're back in school and then we go into statistics. Review this and let me know your thoughts. Thank you very much. Kudos.